All right, hello everyone. Happy Friday. Hopefully we're all behaving ourselves. You guys should have these notes in front of you. And why don't you go ahead and put the page number on these? This is going to be page 130. Okay, there it is. And what we're going to be talking about are the transformations of graphs. So when something transforms, it's going to be changing. So the first thing we're going to talk about are parent functions. So parent functions are basically the function that starts everything off. So you have parents and you probably look similar to your parents, but you don't look exactly like them. So parent functions, again, are the functions that start everything off, and they are the simplest form of the different functions we graph. Now, remember you guys, as you go through this, you can pause, you can rewind, so I'm not going to be waiting for you, so if you need to stop, then you'll have to stop. So some of the different parent functions that you have worked with, so in these, instead of using function notation, I'm going to use y. So some big parent functions are y equals x. There's y equals the absolute value of x. There's y equals x squared. There's y equals x cubed. And there are more after this, but we'll talk about some of those as we go through this. So y equals squared, just so you know its shape, it's a line. Okay, well, my pen's not going to last, so I'm going to switch out here. Y equals the absolute value of x is a V shape. Y equals x squared, we've talked about that. That is the quadratic. Y equals x cubed, we have not talked about that, but here's its shape. And I'll go ahead and put the other one on there. Well, actually, the exponential parent function. So let me add one more up here. So y equals, and so I'll put a number here because I need some number. So let's just put 2. And this shape goes like this. Now, so this is the simplest form of all of these. And what you've ended up doing is, as you know, in middle school, you started adding m and b. And we did that in this chapter as well. We put an m and a b. And what happened is your line, you know, maybe it goes upside down like this. Maybe it's a little steeper than it was or flatter than it was, and it moves up and down. And that's just because we're adding other numbers with the x. And again, those numbers are m and b. And we'll talk about this one some more and this one some more this year. So linear parent function. So let's again just take a little bit closer look at the linear parent function. So now I'm going to write it in function notation. And remember, f of x is just y. So what does this look like? Well, I would just pick some points to graph, and I get to pick for x, and my graph goes from -10 to 10 and -10 to 10. So I'll just pick, you know, -10. I'll pick -5. I'll pick 0. I'll pick 5, and I'll pick 10. You can pick any numbers. So the idea is, if I put x in here, what's y? Well, again, this is y. So if x is -10, then y is -10. And if x is -5, then y is -5, and so on and so forth. Okay? And then I graph these. So here's -10, 10. Here is -5, -5. 0, 0. Here's 5, 5. And there's 10, 10. And then you can take a straight edge, your ID, and you could graph your line. Okay, so this is the simplest of all lines. In fact, it's so easy that if I gave you the line y equals x to graph, it would probably confuse a lot of you because you're used to having an m and a b, and you don't see the m, it's 1, you know, and you don't see the b, it's 0 added on. Okay, so the exponential function, so you need some number. We're not just going to use a letter. So again, here it is. This time I'll use the y. And again, what I would do is pick some numbers. So I'm just going to pick some easy numbers. 0, I'm going to pick 1, I'm going to pick 2, I'm going to pick 3, and I'm going to pick 4. And the reason why I'm picking these numbers is because when I do the math for the x in here, the y's I get will probably be able to fit on this graph because I adjusted where the graph lays. So again, putting 0 in here, 2 to the 0 power is 1, 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8, and maybe you've seen at this point, and you remember that this is g, this is what it's multiplying by, so times 2, times 2, times 2, so times 2. So if you really wanted to, even though it'll never fit on the graph, you could get the other one. So I'm going to graph these. Here's 0, 1, and then 1, 2, and 2, 4, and then 3, here's 3, 8, 4, 16, about there. Hopefully I didn't miscount. And then we should know this shape now. This is a curve, so and we talked about that funny word, the asymptote, so it's not going to cross there. Just make sure it stays above that x-axis. Okay. All right, so these are two examples of parent functions, linear parent function and the exponential parent function. And again, what I would start doing is adding stuff to this, other numbers besides what you just see here. Okay, so we're going to come back to this one in just a moment. Flip over. So let's talk about the different types of transformation. You'll work more with transformations when you get into geometry. Whoops, sorry. So the only thing we're going to talk about here are what are called rigid transformations. And that's when the original function or shape, doesn't matter, stays the same size and shape, but it shifts left, right, up, and down. And again, pause this if you need to because I will keep going. So basically, I'm taking a shape, so for instance a paper clip, and a rigid transformation just moves it around, you know, and I might actually flip it as well or rotate it, but we're just going to work with left, right, up, down. What it won't do is get bigger, so you won't see the paper clip all of a sudden do this. This is called, whoops, well, it's connected. There's another one on here. When it gets bigger, that's called a dilation. So if you've ever gone to the eye doctor and they check your eyes, they put those drops that dilate your eyes. It makes the pupil bigger. So dilating actually enlarges it or shrinks it. Here we're just going to move it left, right, up, or down. So how do you know if it goes left, right, or up, down? So what is going to happen is you're going to have your parent function, and we'll just call it f of x. And again, they don't always use f. Sometimes they use g or h. And what's going to happen is they're going to take the function, and they're going to be putting numbers inside the parentheses and outside of the parentheses. And I actually just realized I messed this up. Typically, this is not h. The letter that they use here is K, so why don't you guys change that? So if the number is inside, so inside the parentheses, inside something. So as you progress through Algebra 2, it won't just be inside parentheses. It might be inside absolute value bars. It might be inside a radical, but it's inside, it's contained. And then you have outside, so it's outside, but again, it's outside the parentheses, it's outside the absolute value bars, it's outside the radical. So just some things to think about, but outside, free to run around and do whatever I want, but this one's contained. So what you're going to do is you're going to look at, and usually it's parentheses, but it could be absolute value bars or radicals. You're going to ask, what makes that 0? And come up with that number. And then if you get a positive number as your answer, it's going to move it right. And if you get a negative number as your answer, then it's going to move it left. Okay? So on the x-axis, positive numbers go right, negative numbers go left. Okay, and the number will be with x. It will be contained with x. So that's the other way you can think about it. Since it's contained with x, it'll move left or right on the x-axis. So if the number's outside, and again we changed it from h to k, what you want to do is you want to add the opposite. You want to make sure it's addition, and then you're just going to use the value as you see it. So if you see a positive number, it's going to shift up, and if you see a negative number, it's going to shift down. Again, pause if you need to. So let's take a look at this one. So here's this parent function that we graphed on the other one. So again, just the points I used before. I'm just copying from the other side. So these are my key points that I was graphing. So here's my original line. With arrows. Okay, so this is the original function, and now I'm going to take a look at what's changed. And there's a 4. So when I look at the original function, the parent function, versus the new function, I want to see what they added. Is it inside or is it outside? So is it inside parentheses, absolute value bars, radicals, or is it outside? Well, it's definitely not inside anything, so it's outside. So that means it's going to go up or down, and since it's positive, it's going to go up 4. And in the homework, I'm going to ask you to describe the transformation. So it's going to be going up 4. So what's going to happen is all of these points, and you can pick any of the points. I mean, I'm just going to use the points that I graphed, and they're all just going to go up 4. And maybe you could use a different thing, like you could use dots instead of points if you get confused. And you know what, this one's going to go off the graph, so you know I could estimate where it is. And then I could graph this one. And so it's not perfect. And this is my transformed graph. It's still the same size and shape, it's just moved up. And if you guys think about this, this is the line y equals x, this is the line y equals mx plus b. My b by itself, where it begins, is at 4, and it goes up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay? So maybe you hear that. That's somebody's phone going off in the background. So anyway, I graphed the parent function. I just moved everything up 4. All right. So let's try this one, and then we'll go to the problems above. So is this the one I did before? No, I used 2. So here's a new one. So I'm going to still use the same numbers, 0, 1, 2, and 3. That's my x. And then remember, f of x is just y. And we're going to graph the parent function, and then we're going to apply the changes. So 0, anything to a 0 power is 1. 3 to the first power is 3. And remember, this is exponential. This is what g is. So they're all just multiplying by 3 every time. So you can keep putting the numbers in here. Or you could just multiply by 3, multiply by 3, multiply by 3. And now I'm going to graph those. So again, here's 0, 1, here's 1, 3, and here's 2. Again, hopefully I did not miscount that, but all right. And now I want to take a look at what this says. So here's the parent function, and now I've added some stuff. So first I'm going to look at the 4. Well, the 4 is inside something. It's inside parentheses. And just so you know, they don't always put the parentheses here, but it's contained. It's contained in an exponent. And so contained in the exponent spot or contained in parentheses, same thing. So what I'm going to do is take this, and I'm going to ask myself what makes it 0. Well, negative 4 in for x would make this parentheses worth 0. So negative 4. And since it's negative, it's going to go left. So I'm just going to put an L for left. And then the minus 2. Again, what I want to do is add the opposite. And I want to look at this as a negative 2. And this is not contained. This is free. So that means with negative 2, it's going to go down. So all these points are going to go left 4 and down 2. This one's going to go left 4 and down 2. Left 4. Let's see, 1, 2, down 2, and that's it. I don't have any more points to graph. And then remember how this kind of flattened off with the last point? It'll flatten off with the last point here. Okay? All right, we are going to take a look at these problems next. We're just practicing describing the transformation, and then we'll come back and take a look at the front. All right, hold on. Okay, again, so this is our parent function. This is a line, but the minus 3, is it inside or outside? So here it's outside. It's a good idea to add the opposite, so you really look at this as a negative 3. Since it's outside, it's going up or down. Since it's a negative, it's going down. So if you want to write the word down, you can, but D3 works. So the next one is exponential. Remember, this is G. This is what it's multiplying by over and over again. And now the minus 2. The minus 2 is in parentheses, but it's also contained in the exponent. So when it's inside the exponent, I want to ask what makes it 0. And then that's how it's going to shift. So what would make this exponent 0 is 2. So since it's 2, that's a positive number, it's going to go right 2. And then here's another line. I've got a plus 4. This is outside, it's not inside anything. So the plus 4, since it's outside, it's positive, it's going to go up 4. Okay? All right, let's go back to the front, look at this example, and then we're going to go to the homework and try some of those, and then your job is to finish it. The substitute is going to have you work to a certain point, then you're going to stop if you need to take the mile marker. If you don't have to take the mile marker, you should keep working on the homework though. So here's f of x. This is just a shape on there. It's nothing that we've ever graphed before. And this time they're writing like this. So here's my function, and I want to subtract 2. So the subtracting 2 is outside of these parentheses. So again, I'm going to add the opposite. And since it's outside, well, that's on the other side. Since it's outside, what I want to do is move it down. And it's going to go down because it's a negative 2. So how do you do this? Just pick some easy points to shift. This one, this one, this one, this one. Those are good easy points. So I'm going to shift this down 2, down 2, down 2, and down 2. And then I'm going to connect my new one. So it goes across, same amount, goes up at the same slope as this one, and then it goes down. So it's still the same size and shape, it's just shifted. All right, so let's take a look at the homework now. So in your homework, you got a couple different parts. One is, given the shape, you create the graph, and then as a challenge on the very back is, I did the transformation. Can you write the function? So sometimes it's written with f of x because there is no function thing that we've graphed that gives us a triangle. But this again, this is a square root of x, which I talked about. Well, I didn't talk about it in our notes, but the square root of x is this curve shape. Okay, so let's take a look at maybe 1 and 3 here, and then we'll jump to maybe do 1 on the next page and 1 on the next page. So first I'm going to look at my triangle, and it says minus 2. So minus 2 is inside. Remember, inside, what makes it 0, and does it move left or right? So what makes that 0 is 2. Since it's positive, it's going to go right. So all these points are going to go right 2. In the sake of geometry, you do need to connect them. So this is kind of prepping you for a little bit of next year stuff. And then to show the difference between the old and the new, they use H, but they put a little apostrophe behind it so you can tell the difference between the original H and the new H, and the same with the other letters. Okay? All right, so you'll try this one. So right now, this is the function x squared. So this minus 4 is outside. You're going to think about how that minus 4 being outside is going to move those points, and then you shift those points. This one, the parent function is this. And what I've done is I've added the 3 and the 2. So this is the parent function. So based on this x minus 3, this is inside. It's inside a radical. So I want to ask what makes it 0. That's 3, and that means it's going to go right. And then this plus 2 is outside. Since it's outside, it's going up or down, and since it's positive, it's going to be going up. So I'm just going to take the key points Mrs. Slauson gave me, and I'm going to move each of them right 3 and up 2. Whoops. So this one's going to go right 3 and up 2, right 3 and up 2. And this one, it'll go a little bit off the graph, but that's okay. I can estimate it. And then how this starts and keeps going, now it's going to start here, and it's going to keep going. Okay? This one's just a shape, so pay attention to how the 4 is in there. Is it inside or outside? Then move the points. Sorry, I know that's a little dizzy. Going to the back. Let's see. Let's take a look at 7. So this is an absolute value shape. I shared this with you in our notes. Absolute value shapes make a V. So the parent function, again, is just this. So what's the minus 3 do? What's the minus 2 do? Well, minus 3 is inside. It's inside brackets. So what makes it 0 is 3. It's positive, so it's going to go right. And then the minus 2, maybe you want to, add the opposite. And now that it's negative and it's outside, it's going to go up or down. This is going to go down 2. And you don't have to write the negative 2, but the negative just reminds me it needs to go down 2. So what points should I change? Well, just pick some points. Like, these are good points to pick. So for instance, this one's going to go right 3 and down 2, and it's actually going to end up right on top of the original one. Nope, down 2, sorry. And this one's going to go right 3 and down 2, and this one goes right 3 and down 2, and this one goes right 3, down 2, and the other one, you know what, you can estimate right 3 and down 2, and then just graph your new points. And make sure you put arrows where arrows are supposed to go. And when I see you guys, whoops, a straight edge would help here. We'll come back and revisit domain and range on stuff like this. All right, so you try the rest of these. They're all pretty simple. Just so you know, on number 9, the parent function is this, which is graph for you. So what's the minus 4 doing to it? Okay, all right, so what about problems like this? So I did put B for before and A for after on all of them. And what you want to do is just, we're going to use f of x on all of them. And you want to think about, okay, should I have x with either plus or minus a number, which would be h from our notes, and then do I want plus or minus on the outside? So I want to see, did it move left or right? And if it moved left or right, you're going to put a number here. And I would write this down. And if it moved up or down, you're going to put a number here. And if it did both, you're going to have 2 numbers. So, and you don't have to do all 3 points. Pick 1 point to work with. So this is my before P, this is my after P. So what happened? Well, it went left 2. And then from there it went down 3. Okay? So how do I write left 2? Well, since it's left and down, I'm going to have something in the parentheses and something out of the parentheses. So left 2. Left 2 you should view as negative 2. And so you need to make the parentheses that would give you negative 2 as your solution. The other trick is, if this is negative 2, you're going to add 2. Because when I put negative 2 in there, I get 0. So whatever this is, you put the opposite of it in. Then down 3, well, again, we always looked at this as addition. Down 3, it's just, down 3 means negative. So it's negative 3. And let's do one more. Let's do 15. So again, here's my before, here's my after. It is moving left and down, so I'll have 2 things. So here, I'll put this one here. So something in the parentheses and something out of the parentheses. So I'll start with S. It went 1, 2, 3, 4, 5, 6. So it went left 6, which remember you want to look at as negative 6. And then after that, it went 1, 2, 3, 4, 5, 6. 6 again, and it went down 6, which I'll look at as negative 6. So I'll put the X here. And then on this one, remember, I took what made it 0, and it went here. The trick is just do the opposite. So if I have negative 6, you do 6. So what makes that 0? Does negative 6 make it 0? It does. And then this one, you just put it as is, plus negative 6. Now you try the rest. And again, in a little bit, you're going to be doing the mile marker. If you are don't have to take the mile marker, then you can keep working on this. And again, this one on page 131 and the notes one on 130. And I will see you on Wednesday. Have a good long weekend.